Thank you, Brian, and thank you for the brief introductions. Good afternoon, everyone, and thank you for joining Reliability First for this webinar presentation on upcoming changes to NERC Reliability Standards Framework for establishing and communicating system operating limits, or SOLs. Before we go any further, I do want to note that many of these slides have quite a lot of text on them, but as Brian mentioned, the slides are publicly posted and will be available to you to review afterwards. We will generally not be reading the contents of the slides to you verbatim, and we encourage you not to attempt to do so either as we go through this presentation. But for the next 30 minutes or so, I invite you to pay attention to our presenters, as I know that they have some valuable content to share with us. Next slide, Brian. Brief introductions, and Brian already did part of this for me, but my name is Stephen Waite, and I joined Reliability First in April 2021. I am in the Operations and Planning Compliance Monitoring Group, as Brian stated. Prior to joining RF, I worked for investor-owned utilities in electrical engineering roles, such as system protection, distribution automation, and distribution planning. But my bio doesn't include experience in operations planning or real-time operations. So I'm very happy to be introducing my co-presenters, Vic Howell and Dean LaForest. And as Brian mentioned, they both served on the standard drafting team. Vic is the Director of Reliability Risk Management at WEC and has more than 25 years of experience in both the Eastern and Western interconnections, working for multiple entities. Most recently, before joining WEC, Vic was with the Reliability Coordinator for the Western Interconnection. So that worked very well with his role on the standard drafting team and chairing that drafting team from 2015 to 2019, as Brian mentioned. And Dean is currently with ISO New England, as Brian mentioned, and oversees their team of operations engineers. Dean served on the project standard drafting team for its entire duration and chaired it from 2019 through the conclusion of their work in 2021. Dean has more than 30 years of experience in planning, operations, and capital projects. Next slide, Brian. This slide outlines the order of topics for this presentation. I'm going to begin with a brief background of Project 2015-09 before turning the presentation over to Vic and Dean for the meat of the presentation. Vic will begin with SOLs and SOL exceedances, discussing those concepts in the operations planning and real-time operations time horizons. Dean will then pick up with some additional discussion of SOL exceedances before turning to changes in the transmission planning horizon. After some concluding remarks from Dean and myself, we expect to have time for a question and answer session based on questions that you submit through Slido. So we encourage you to participate in the Slido session and submit questions there if you have them throughout. Next slide, Brian. And then one more. So a brief background of the project. This project resulted in the changes that we're going to be discussing today, and it was initiated in 2015 in response to a periodic review of standards containing requirements for determining and communicating system operating limits. The stated goals of the project coming out of that periodic review included eliminating overlap with transmission planning requirements, enhancing consistency with transmission operations, that is TOP, and interconnection reliability operation standards, that is IRO standards, and clarifying acceptable system performance criteria in the operations time horizons. Next slide, Brian. Skipping forward about 5.5 years, because this was a fairly lengthy process that I'm sure the standard drafting team members could be bribed with a beverage purchase to discuss at length. Including several iterations of draft standard revisions and industry ballot and comment periods. But skipping over all of that, the proposed standard revisions and NERC glossary definitions changes passed final ballot in April and May of 2021. NERC subsequently petitioned the Federal Energy Regulatory Commission for approval, and FERC approved in March of 2022. The effective date for these changes is generally April 1st, 2024. But please reference the implementation plan if you have questions on implementation timing for any specific requirements or specific details, because there are some requirements that have a little bit more time allotted for initial compliance. And with that, I'll turn it over to Vic and take it away, Vic.
Okay, thank you, Stephen. So as Stephen mentioned, several standards were modified under NERC Project 2015-09, and we'll talk later about some of those changes that occurred in several other standards. But right now, I'm going to focus on the changes in FAC 11 and FAC 14, as well as a few key changes in some definitions. Next slide, please. So as Stephen mentioned, all of the standards and definitions that were modified under the NERC Project 2015-09, they become effective on April 1st of 2024. And these revisions focus primarily on aligning the FAC standards and the treatment of SOLs to the TOP and IRO standards. So what do I mean by that alignment? So back in 2014, there was a NERC project called 2014-03 that significantly revised the TOP and IRO standards and some of the key definitions, and all of those standards became effective in 2017. In fact, April 1st of 2017. So some of those standards require TOPs and RCs to do some key activities. They require TOPs and RCs to perform operational planning analyses, or OPAs, to identify SOL exceedances. They also require TOPs and RCs to develop and communicate operating plans for any SOL exceedances that are identified in that OPA. They also require TOPs and RCs to perform real-time assessments, or what we call RTAs, at least once every 30 minutes. And then TOPs are required to implement operating plans for any SOL exceedances that they see through its real-time monitoring or its RTAs. And then there are some notification responsibilities between the TOPs and RCs. And you'll notice something in common as I've described those requirements. They all use the phrase SOL exceedance. The standard drafting team and its predecessor, the periodic review team, we learned a couple of really important things as we began our work. One of the things we learned is that TOPs and RCs across North America had very different ideas of what SOLs were and what it meant to exceed them. And I won't take time here to really describe what those differences are, but suffice it to say, they were literally all over the map. So the concept of what an SOL actually is and what it means to exceed one is such a fundamental and foundational thing. And it really has broad impacts to reliability and the very meaning of several requirements in the reliability standards. For example, I mentioned that several TOP and IRO standards use the phrase SOL exceedance. But if SOL exceedance means one thing to this TOP and means something very different to that TOP, then those standards that reference SOL exceedance then have completely different meanings that can result in a completely different reliability outcome. So because of that, the standard drafting team acknowledged that this was something that really needed to be resolved. So the drafting team sought out to clarify what an SOL is in a way that didn't allow for a myriad of interpretations like the former or currently effective definition does. And we also sought to clarify what it means to exceed an SOL. So we really believe that one of the byproducts of clarifying these two things in particular is, in essence, a clarification of other standards and requirements that use that term SOL and use the phrase SOL exceedance. And we believe that this clarification, along with the structure and content of the revised FAC 11 and FAC 14 standards, achieves that alignment that we're talking about here with the TOP and IRO standards. So when you sort of step back and look at the big picture, we now have a set of definitions and standards that clearly describe what SOLs are, describe what it means to exceed them, and then what TOPs and RCs are supposed to do when SOL exceedances occur, both prior to real time through OPAs and in real time through RTAs and real-time monitoring. Next slide. So the definition of SOL, here's the revised definition. It's all facility ratings, system voltage limits, and stability limits applicable to specified system configurations used in BES operations for monitoring and assessing pre and post contingency operating states. So this definition clarifies a few things. One, it clarifies that SOLs are used for operations monitoring and for assessing the pre and post contingency states. And this brings with it the idea that SOLs are used in the operations horizon, and Dean will speak more to that when he speaks. In the operations horizon, the assessment of the pre and post contingency states is achieved through the OPAs, through the operational planning analysis prior to real time, and then through real-time assessments and real-time monitoring in real time. Another thing that this definition clarifies is that all facility ratings and system voltage limits are SOLs all the time. And now for some, this may be a very different concept of what SOLs are, but to others, it might not be. Facility ratings and system voltage limits, they are an input into OPAs and RTAs. And it's the OPAs and the RTAs that tell you if any of those facility ratings and system voltage limits will be expected to be exceeded in the pre or post contingency state. Now, stability limits are unique in that they are often an output of a study, and they're generally in place to prevent the system from going unstable in response to certain contingency events. For example, a stability limit might be established as a flow limit on a collection of lines or an interface of some sort. And so long as real-time flow remains below that limit, the system would not be expected to go unstable if the critical contingency were to occur. However, if flow is above that limit, then if the critical contingency were to occur, then the system would be expected to go unstable. Stability limits are also an input into OPAs and RTAs as well to determine if those limits would be expected to be exceeded. System voltage limits, the drafting team saw a need to create a term to address system voltage limits. The existing standards speak a lot about voltage criteria and voltage limits lowercase, but the drafting team saw a need to clarify exactly what's meant by a voltage limit, hence the development of this term. Next slide, please. Okay, so let's review a few key requirements in FAC 11. Requirement R1 is pretty straightforward. RCs are required to have a documented SOL methodology for establishing SOLs within its RC area. This is not new. Requirements R2, R3, and R4 were intentionally crafted to align with the revised definition of SOL. For example, R2 speaks to facility ratings, R3 speaks to system voltage limits, and R4 addresses the establishment of stability limits. With respect to R2, one key aspect of this requirement is that TOPs and RCs use common facility ratings. And now we understand that there's a lot of focus on FAC 8 regarding the establishment of facility ratings and the accuracy and correctness of those ratings. And I wanted to clarify that FAC 11 and FAC 14 do not address the accuracy of those facility ratings. It only addresses the common use of facility ratings between the RC and its TOP. So those standards, FAC 11 and FAC 14, are written under the notion that the facility ratings that we're talking about here are correct. Now, that said, as an aside, it is good operating practice to validate facility ratings whenever exceedances occur. Requirement R3 addresses system voltage limits, and it's got a handful of subparts there. And the subparts to requirement R3 specify some boundaries, if you will, for system voltage limit establishment. So the idea here is that when TOPs when TOPs go about determining system voltage limits for their TOP area, they need to do so in accordance with these subpart requirements. I'm not going to get into the details here. They're spelled out in the requirement. Requirement R4 addresses the establishment of stability limits, and there is quite a bit here, but I wanted to point out a few main topics here. One is that there needs to be clear criteria for establishing stability limits, and that's addressed in part 4.1 and its subparts. Also, stability limits need to be established then to meet that criteria. Requirement R4 also clarifies that RCs are responsible for establishing stability limits that impact more than one TOP or impact other RCs. And there's a companion requirement for this in FAC 14 that specifically requires RCs to do that. And then there are other subparts that provide additional clarity and transparency with regard to stability limits. Another thing that became clear to the drafting team was that there was a lot of confusion and inconsistencies in the contingencies that TOPs and RCs were using for the various aspects of their work. So contingencies are addressed in requirement R5 in the subparts of R5. The drafting team acknowledged that different contingencies are used for different things and that there is some flexibility needed to allow for that. However, there was also some need to provide some needed clarity. For example, the language in R5 conveys the ideas that TOPs and RCs may use one set of contingencies for the establishment of stability limits, and they may use a different set of contingencies for their OPAs and RTAs. And both sets need to be clearly described in the RC's SOL methodology. Another big issue was with regard to the treatment of multiple facility contingencies, like common tower contingencies or common right-of-way contingencies. FAC 11 R5 addresses this issue in a risk-based manner by requiring RCs to specify in its methodology any multiple contingency events or types of events that need to be used for the establishment of stability limits and for the use in OPAs and RTAs. Next slide. So FAC 11 specifies everything that needs to be in the RC's SOL methodology, and FAC 14 addresses the responsibility for establishing SOLs. And it also specifies what folks are supposed to do in relation to the RC's SOL methodology. So RCs are required to establish IROLs for their RC area. They're also required to do so in a manner consistent with their own SOL methodology. Dean is going to talk a little bit more about IROLs, so I won't get into that here. Each transmission operator is required to establish SOLs for its portion of the reliability coordinator area in accordance with its RC's SOL methodology. Now, it's interesting that prior versions of FAC 14 use the language to establish SOLs consistent with its RC's SOL methodology, and we thought that introduced some confusion. The idea here is that when TOPs set out to establish SOLs for their TOP area, they need to look to their RC's SOL methodology, and they need to establish SOLs the way their RC SOL's methodology says to establish them. The TOPs are then required to provide those SOLs to its RC. Again, none of that is new. The revised FAC 14 clarifies that RCs are responsible for establishing stability limits that impact more than one TOP or other RCs like I described earlier. And this is the companion requirement that we see in FAC 11. FAC 14 R5 and its subparts require each RC to provide SOL and IROL information to PCs, TPs, TOPs, GOs, and TOs. And the drafting team's intent here was to focus on the information that's important for the RC to communicate and to whom. I won't go into the details here, but I will call out one thing. Part 5.6 was specifically included to address a directive from FERC staff that TOs and GOs need to know the list of their facilities and associated contingencies that have been identified as being critical to the derivation of an IROL. So this particular subpart requires RCs to communicate that information to TOs and GOs at least once every 12 calendar months. Next slide. So what does it mean to exceed an SOL? As I mentioned, this was a major issue. The drafting team considered various approaches on how to address this. And one approach we considered and tried was to actually create a NERC definition for SOL exceedance, but that failed pretty miserably. So after a few attempts, we settled on what FAC 11 calls a framework for SOL exceedance. So this framework is described in FAC 11 requirement R6. So this requirement says that each RC shall include the following performance framework in its SOL methodology to determine SOL exceedances when performing real-time monitoring, real-time assessments, and operational planning analyses. And then it goes on to specify what that framework is. So this framework is intended to sort of represent the floor for SOL exceedance. It's the essential and minimum characteristics of SOL exceedance. The intent there was to create a common fundamental description of SOL exceedance across the industry, so that when TOPs and RCs go about determining what it means to exceed an SOL, the idea here is that at a minimum, it should mean what is specified in that framework described in R6. Now, it may mean more than that, depending on RC's practices, but sort of the solid core, if you will, is captured in R6 and its subparts. So while the requirement in R6 describes SOL exceedance, the SOL exceedance framework, requirement R7 describes when SOLs need to be communicated. And for this, a risk-based approach was taken such that there are certain types of SOL exceedances that must always be communicated, and there are other types of less risky SOL exceedances, potentially, that must be communicated only if they persist longer than 30 minutes. So we think we've made some pretty significant improvements there. And Dean's going to talk more about this, but changes were made to the corresponding requirements in TOP 001 and IRO 8 to ensure that the RC's SOL methodology is followed when communicating between the TOP and RC about those exceedances. Okay, next slide, please. Okay, so for the next couple of slides, we thought we'd put together and show a few examples that exemplify what we've characterized as the SOL exceedance framework. And a lot of these same examples are pointed out in the revised SOL white paper, if you're familiar with that. So I'll walk through this example. In this scenario, this is a transmission line, and it happens to have these three ratings. There's an 800 MVA continuous rating, there's a 900 MVA 4-hour rating, and there's a 950 MVA 15-minute rating. And let's say that in this scenario, the actual flow that's being observed in real-time monitoring through their SCADA systems is somewhere less than 800 MVA. And then they run their real-time assessment, and this entity happens to be using real-time contingency analysis, or RTCA, for that. So when RTCA runs, it indicates that the post-contingency flow lands somewhere, if the contingency were to occur, lands somewhere between 900 and 950 MVA. Now, the question then becomes, do I need to take action now, pre-contingency, or can I wait and see and take post-contingency mitigations if this contingency were to occur? So the question then that needs to be answered is, okay, if this contingency were to occur, what is my operating plan? And how long would that post-contingency operating plan take? So in this example, the entity knows that, well, I'll need to do this, I'll need to ramp down this generator, I may need to close this breaker, and that operating plan will take about 30 minutes to do. So in this case, because the operating plan would take longer than 15 minutes, pre-contingency action is required to bring the new post-contingency flow to a value less than 900 MVA. So that's what the entity does here, the TOP. Okay, here's another example in the next slide. Similar situation, the actual real-time flow is at somewhere less than 800 MVA. And when they run real-time contingency analysis, it indicates that the post-contingency flow would be somewhere between 900 and 950 MVA. Brian, if you can hit down real quick. There we go. So here's what the post-contingency flow is. Now, all of a sudden, lo and behold, that actual contingency occurs in real life, and suddenly the actual flow is right where RTCA said it would be. So now you have a real-time flow of somewhere between 950 and 900 MVA. So in this case, it was okay to implement a post-contingency operating plan. So that's what they do. They implement the post-contingency operating plan to bring that real-time flow to a value less than 800 MVA. And then RTCA runs again. And this time when RTCA runs, it shows that the new post-contingency flow is somewhere higher than 950 MVA. And this is a situation where pre-contingency mitigation is required. So they take actions to bring that new final post-contingency flow to below the 950 MVA mark. So those are just a couple of examples that we think exemplify what we've characterized in the SOL exceedance framework. So at this point, I will turn it over to Dean LaForest, who will take you through the rest of the presentation.
Thank you, Vic. Once the team got the essence of FAC 11 and FAC 14 down, we did a long look at how those revised standards would interact with the existing set of standards. And lo and behold, we found some obvious ones and less than obvious ones. The obvious ones are described in this top set of bullets. How do you actually utilize these standards with actual SOL exceedances? And it just so happens there's standards in TOP1 and IRO 8 that discuss how the TOPs and RCs identify SOL exceedances, how they discuss actions taken. And what the drafting team found was probably the best way to capture what was now added in FAC 11 was specifically to add new requirements in TOP1 and IRO 8, which stated explicitly that the RC's methodology was to be used when determining these SOL exceedances in all the appropriate places, real-time assessments, real-time monitoring, and when you're looking for potential exceedances when you're setting yourself up for a successful next day from their operational planning analyses. That was seen as a good way to sum it all up. Folks actually were supportive of that. And with those down, and as you see in the middle, the existing requirements salted away, we started talking about what now was a consequence of having a pretty solid set of guidelines within which to identify SOL exceedances. And many participants were bringing up the point that with solidifying what constitutes an SOL exceedance, they potentially had lots of exceedances to potentially now deal with, which brought us to the third set of bullets you see here. How are communications dealt with? And as Vic noted, we added an R7 and FAC 11 to describe in the RC methodology a risk prioritization, which SOL exceedances are discussed first, which ones can be left out. And then these were brought in and discussed and described in, again, TOP1 and IR08, where not only did we include the notification requirements, but we provided examples that industry participants agreed were not necessarily a heavy lift, but would constitute adequate documentation to show that these communications had occurred, and it provided assuagement to folks who had concerns about now having a pretty clear set of SOLs and SOL exceedances. Next slide, please. I'm going to summarize where we got to and speak again briefly about FAC 10. Next slide, please. So early on in the drafting team's discussions, it was pretty obvious that entities kind of industry-wide were in large agreement with the retirement of FAC 10. Determination of SOLs in planning space didn't make a great deal of sense since there were operating limits. But there was a recognition that when the initial set of standards went into place in 2007, FAC 10, FAC 11 kind of had a handshake agreement. There was an understood and expectation that there was information being shared from planning entities to operating entities and operating entities to planning entities. And that understanding led to a discussion and actually a couple of new requirements in FAC 14, which we show here in this slide. That handshake of data and criteria used in both spaces was captured in R6. I would paraphrase this to be the requirement that basically says planning shall design their system at least as conservatively, as the criteria used for operations, or explain why. That's the euphemism that we came to know R6 by. It shouldn't be a heavy lift. We would expect operating entities to be using the facility ratings provided them. The same rating should exist in planning space as an operating space for the same piece of conductor hanging in the same air as exposed to the same ambient conditions. So that was not thought to be a heavy lift for the industry as a whole. R7 and R8 were slightly more involved, and they involved, in the cases of R7 and 8, the planning coordinator providing information to entities. In R7, the planning coordinator providing information on caps that they were doing that were going to address instability. R8 was to give information to basically SIP2 hardware and facility owners, those that needed identification of those facilities that had the medium classification, that needed to know whether their facilities were critical to the derivation of an IROL or were a contingency that could cause an IROL. R8 now provides a means of communicating that information to those asset owners. R5, which is not noted here, gives the reverse. It provides a requirement that operating entities have to provide IROL and stability related information to planning entities. Again, it's that handshake of information exchange so that both worlds, both silos, are aware of the more problematic operating concerns, and planning can look at them and address them and then hand back to operations what they've been found. Next slide, please. As I said, when we looked at the other standards as we made changes to FAC 11 and 14, we found a lot of them involved. Specifically, many were involved with the retirement of FAC 10. So the drafting team made modest changes to a number of the standards. They're called out here largely. I'm not going to read this verbatim, but in essence, it was typically one of two changes. It was either with the retirement of FAC 10, we had to replace a FAC 10 reference with some more specific language, or with regard to IROLs, the group attempted to make a change in IROLs, which I'll describe shortly, but we were not successful. So what we attempted to do to get a more consistent application and utilization in the standards, we replaced the term IROL with language that better described the functional performance that we were seeking. Next slide, please. And finally, let me get to some concluding thoughts and then open it up for any questions you might have for Vic and I. As I said, the retirement of Fact 10 was sought. It was what industry thought that they agreed on was needed. And the remaining changes in Fact 11 and 14 helped accommodate what was done. We provided 2 new definitions, which Vic gave you a description of. We think, and I believe with the support from industry in terms of our approval rates, they thought we did a better job with the revised standards of handling what an SOL is and how they could then be used to determine SOL exceedances with associated changes in other standards. For the first 3 or so years of our drafting team, we attempted to deal with the subset topic of IROLs. As you all know, they're the more interesting version of SOLs, and they became such an important topic of discussion that the drafting team and NERC decided our drafting team wasn't the proper home for these. We created a separate group, the MEITF, which you can see noted on the last line, and they met for over a year and adopted some industry vetted technical documentation on IRLs. I suggest if you're interested in that you take a look at it, and you can let us know any later questions. Vic and I are not really looking to discuss IRLs today here. We're looking to address any questions you may have in the standards we supported. So with that, I suggest we move to the next slide and presumably any questions you folks may have.
Thanks, Dean. I recognize I'm standing between us and the Q&A session, so I'll be fairly brief. One of the benefits and perhaps the hubris of facilitating this presentation from an RF perspective is that I feel obligated to give some closing remarks. So if you want to know what RF hopes you take away from this presentation, make a note to revisit this slide once the slides are posted. I'm going to start with reliability coordinators. So this one may seem obvious, and perhaps it is, but beginning April 1st, 2024, a new version of FACT 11 will be used to assess your SOL methodologies. So we encourage you to work proactively and collaboratively with your transmission operators to make any required updates in a timely manner. Transmission operators, likewise, you will be impacted by the new SOL methodologies, and you will be expected to implement those updates to your RC's SOL methodology, and we encourage you to work proactively and collaboratively with your RC to understand and implement any changes made to the methodology. Turning to the planning horizon, planning coordinators and transmission planners will have a little bit less of a compliance load with FACT 10 going away, but do not sleep on the new requirements in FACT 14. We'd encourage you to have a plan for accounting for the criteria in the RC's SOL methodologies so that your planning assessments are using at least as restrictive criteria, as well as have a plan for making the necessary communications that Dean alluded to earlier. Transmission owners and generator owners should be on the lookout for communications from reliability coordinators and planning coordinators regarding potential changes to applicable facilities for the standards that I've listed on this slide. So please don't be hesitant to reach out to your RC or your PC if you're expecting one of those communications, or if you have questions about if and when that communication is expected. And then 3 final takeaways for all impacted entities. Please review and understand the implementation plan timeframes if any of these standards are applicable to you. We keep mentioning April 1st, 2024, and most of the changes are effective April 1st, 2024, but there are additional details in that implementation plan that may impact you. Secondly, please do not leave evidence generation and retention or internal controls as an afterthought. The earlier you start thinking through those things, the better positioned you will be for any changes to the methodology, communication requirements, any of the changes that would impact you. And then lastly, if you have questions or need help, please don't hesitate to reach out to your ERO region. If you're in the RF footprint, RF has an entity engagement department that runs an assist visit program that's available to you free of charge. Please feel free to take advantage of that. If you're in another region, I'm sure there are similar offerings from other regional entities that may be appropriate for your company to take advantage of. And with that, I thank you all for your attention, and we'll turn the presentation over to Brian to facilitate the question and answer session.
Stephen, Dean, Vic, thank you so much for your time. Thank you for your detailed analysis of all these changes. This presentation was a lot. I'm old enough to remember when an OPA was called a day-ahead study, which is what I used to do in my past life. A lot of really great information here. Maylee, this presentation will be repeated on WEX platform. Do you have the date for when this webinar will be repeated on the WEX platform?
April 20th, and that will be at 2 p.m. Mountain Time.
All right, April 20th, 2 p.m. Mountain Time. So if you watch this presentation and you have questions and you're still trying to digest this, or you're thinking to yourself, I really wish I would have brought my, my planner or my shift supervisor or my ops engineer on this call. April 20th, you could go to wec.org and you can check out their calendar, all of their upcoming events. April 20th, 2 p.m. Mountain Time. You'll get another chance to relive this presentation. And as Stephen said, you could always reach out to your respective region, whether it be Reliability First with our Assist Visit program, or really any region that is your lead. Please reach out to them with any questions regarding these standards, the implementation plan, or ideas you have about internal controls.